Hey everyone. Today I'm going to talk about how to implement a traffic speed radar in Python using OpenCV. And this is part of my image processing project at Vellore Institute of Technology. So without further ado, I'm going to get started. So road safety is an integral part of modern roads. And in modern cities, we see more and more speed cameras being used. So even though some drivers would not like speed cameras because it catches them and they end up paying a high fee, it is important so as to maintain safety on roads and make sure that people stay within the driving limit, and we can try to reduce accidents using this way. So initially, speed cameras used to use something called the Doppler effect, and by measuring the change in frequency, we're able to measure how fast a vehicle goes. But now speed cameras have a lot more than just measuring frequency. They have a lot more sensors, and they can find different things such as the speed, whether a vehicle is going in the wrong lane, or maybe even if someone is not wearing a seatbelt or is eating food inside the vehicles. So as time passes by, speed cameras are going to get more and more advanced. So moving on to the literature survey, I basically looked into 5 papers. And to summarize these papers, the main ingredients that I'm going to use for my project is the speed measurement tool. So how this is going to be done is we're going to start the timer at a certain segment of road and end the timer at another segment. And using that, we'd be able to find the time that's elapsed. And based on the distance, we can estimate how much speed the vehicle is going in. Also, to find out the vehicle, we're not going to be using CNN or any kind of artificial intelligence. What we're going to use is an image processing concept known as image subtraction. So some of you may already know this. Image subtraction is used to find the difference between two frames. So in a speed camera, the background is usually the same. The only thing that changes is the vehicles that come in front of the background. So to capture only these vehicles, subtraction is able to find the difference between the foreground and background solely based on the movement. So moving to the problem statement of the project, there are mainly 3 stages, main stages, and that is the vehicle detection, the speed estimation, and then capturing the vehicle image. So for vehicle detection, as I said, we'll be using image subtraction. For speed estimation, we'd be using distance elapsed, which if you didn't understand, you'll understand with an image later. And capturing vehicle image is basically cropping the image and saving the image of the vehicle. Now, the reason I'm not getting number plates of the vehicle is because the clarity of the video wasn't that great. So we can't see the numbers also in the number plates. So because of that, I thought that we just get the image of the vehicle and associate it with the speed that it's gone in. So this explains more about what I said. So here's the diagram for my project, and this gives a clear idea of what's going on. So basically, in the video acquisition part, we define a region of interest. This is a small portion of road where we just want to measure movement and the vehicles that go. In image recognition and region of interest monitored, what we have is first step is image subtraction, which helps us find where the vehicles are. Masking is used to make the image binary, and by that I mean it will make it black and white, or ones or zeros. So the vehicles would be white and the background would be black, and with that we'll be able to pinpoint where the vehicle is. Erosion I used basically to distinguish the foreground in the background. Sometimes what happened is when two vehicles are going close by, they kind of get detected together. So with erosion, we're able to find the difference between the objects. Contra detection is a way of finding the shape of the vehicle that's coming in, and it saves the details of where it is and draws the bounding box accordingly. Now, object tracking is something that's really important in this project that's used. And the difference between object recognition and object tracking is that tracking specifies an ID to a particular vehicle and it follows that vehicle around. Whereas in object recognition, we just find out that object and we don't see where the movement is. So object tracking is basically used for videos more often. Speed calculation is where we start the timer and end the timer when a car crosses a particular segment of road. And based on that, we calculate the speed. And then finally, we save the vehicle image to a file, which I'll show later. So this is what I was saying. This is the image that we have. And after masking, this is what it looks like, where the white places are vehicles and the black is the background. Now there is some small white areas, but we're not going to consider those because we have a threshold of area, which avoids other things which are not vehicles. Finally, we detect contours. We eliminate based on the area of the contour. And we have an object tracker to give an ID to the vehicle and track the object. So this is how it works. This is where we start the timer. This is where we end the timer. The original video will have the line, so you'll know. And as soon as we end the timer and calculate the speed, at a particular part, we capture the cropped image of the vehicle and we save it to a particular file. So yeah, not only do we actually save the image to a file, what we do is we also make a summary. So this is basically creating a text document and entering the ID of the vehicle and the speed. So in this case, the speed limit is 80 kilometers per hour. So if a vehicle exceeds the speed limit, what we do is we pinpoint it with exceeded. And also there's a summary of the vehicles that's crossed, the total amount of vehicles, and the vehicles that has crossed the speed limit. So yeah, these are all the screenshots from the document. This is the speed estimation, and this car has crossed the speed limit over here. This is the saving of the images of all the vehicles that has crossed. And over here, we have the summary and the ID and speeds of the vehicles. So there were some challenges that I did come up with while creating this project and progressing with it. And here's a brief pointers on the challenges that I faced. So first was objects that weren't vehicles were being detected. So basically what happened was in this image, a huge segment of the road would suddenly light up with a rectangle and it'd say that was a vehicle where it wasn't a vehicle. So the main issue with that was the masking, and I changed the masking method after referring to the net. And with a better masking, I was able to get this kind of an image over here. And with this, I was able to identify vehicles better. Number plates were unreadable. So the initial project had the idea of reading the number plates as well. But since the video wasn't that clear, we couldn't read the number plates at all. That's why we stuck to just taking the picture of the vehicle. Next is multiple vehicle speeds were unable to be detected. So what happened is when there was one vehicle that was crossing a segment of the road, the code worked fine. But when there were multiple vehicles, the code malfunctioned and it was showing a wrong output. So I fixed this later and I'll explain how I fixed it later in the code. Vehicles close together were clubbed as a single object. So the way I fixed this issue was to erode, as I had mentioned earlier. So by eroding the masked image, we were able to differentiate between two objects that were apart. And also I moved the detection lines a bit further back so that we'd have a clearer image of the vehicle. And I moved it as far back as I could. So yeah, I'm going to move on to the project implementation now. So for project implementation, we basically have two files, SpeedRadar2 and tracker. So yeah. So in the radar, the tracker is basically used for object tracking and to find how the vehicle moves. So I'll come to that after explaining the speed radar. So what this does is, here we have the background subtraction. And this is what finds the difference between the foreground and background. These kernels, these are basically used for the masking technique that I used. So initial masking technique that I used did not work. That's why I'm using the second masking technique. And while true, this is basically, if you've learned OpenCV, you know that to make a video, we'll basically have to loop it and use a range of images. So this is a looping function for that. And here we're just reading the image. Here, the region of interest is extracted by taking the frame and finding the space based on the coordinates. So this is, this is to find a better idea of which region we're interested in. And we don't want the whole frame in the screen. We just want a part of it. Masking method 1 was which did not work initially. So this could be discarded and this is not really needed in the code. Different method of masking. And this is the one which works later. You can see that this erode was added later because it was showing the issue of detecting multiple vehicles as one. So Contra Detection, mainly what it does is it finds the shape of the objects that are detected, and it saves the details of where it is and how big the image is. So if you see, we're going through each of the counters, and this is the threshold of finding vehicles. So using trial and error, I found out that if it's above 1,000, that means it's more likely to be a vehicle. And if it's less, then we can ignore any of those cases. So this is the main code for object tracking, and this calls the other Python function to find out if an object belongs to the same ID or not. So in this part, what we normally do is that there's an if-else case. So we have something called a getSP, which is a function of tracker part2. So if the speed is lesser than the limit, which in this case is 80 kilometers per hour, it would put a green rectangle. And in case the speed goes above that, it would put an orange rectangle. So this is basically for the aesthetics and making the looks better. And we can have a clear view of which vehicle crossed the speed limit. And now tracker.capture, this is a function that's called so as to save the image of the vehicle. So all these functions are there in tracker 2, and I shall be showing those quick. Now cv2.lines, these lines are basically used to draw it on the video itself, and it gives a better idea of when the timer starts and when the timer ends. So the reason there are 4 lines and not 2 lines as were the PPT is because sometimes when the vehicle crosses a particular line, it did not sense it. So I needed to use a small segment of the road so as to start the timer and end the timer. Finally, we display the event. And tracker.end is something that's used to create the text files. So this is needed only when we're closing the implementation. So I'll just run the implementation quick before showing tracker. So I can see the ID is specified to the vehicle and it keeps following him. So the 0 is the ID that's shown and the speed is 47 right now. So this is the second vehicle with an ID 1. And when it crosses this red segment of the road, the speed is estimated. So it's going at 57 kilometers per hour as per our program. So you can see that car has actually crossed the speed limit slightly by 87. So it came in an orange square and it will be saved later, saying that it crossed the speed limit. So initially there used to be an issue with multiple vehicles coming in together, but right now that's fixed and multiple vehicles are shown without any issues. Yeah, towards here they converge, but that's not really much of an issue. Okay, okay, fine. I thought that vehicle crossed the speed limit. Okay, so now I'm going to go and explain tracker. So in tracker, what we have is we have defined the limit clearly, 80 kilometers per hour, and we open a file. So this is basically to put in the summary and the speeds of vehicle. And I'll show the file later, how it's created. Okay, so over here, what we have is basically the function so as to track the object that's there. And update is the main function that we use so as to see if the object is the same or not. So what I mean by this is when an object slightly changes in its frame, we need to see if it's the same object or not. So how we do that is finding the distance between an object in frame 1 and frame 2. So when a car is slightly, let's say in the 8th pixel, and it goes up maybe to the 7th pixel, so then we can say that it's the same object itself. So this mainly finds the distance between two of them. And it's like a threshold. So if we increase this, then it will detect multiple objects for the same object, and it will show multiple IDs. And if we decrease this a lot, then multiple vehicles will get the same ID and would be considered as one. So if you're using a different video, it's important that you check out for yourselves and try to get the correct distance threshold so as to correctly track vehicles. Also, if you're using a different vehicle, there's a bunch of numbers are going to change, such as these coordinates over here, when to start the timer and when to end the timer. Also, where to draw the lines, you'll have to like change those accordingly based on the video that you're taking. So this is used to start the timer when the vehicle crosses the first line. And over here, this is used to stop the time. So as you can see, I've actually used an array so as to start time and stop time and not used a single integer. So my earlier mistake was that I used a single integer itself to calculate the time difference. And the main problem with that is it will not consider if there are three vehicles in the same segment, and when the first vehicle crosses and the second vehicle comes in, it creates a mess generally, and it's not able to see which car starts the timer and which car stops the timer. That's why I created an array based on IDs. So ID 0 car would have its own start and stop timer, and ID 2 car would have its own start and stop. Now this is basically a flag that I just generated so as to capture the image of the vehicle. So the moment this crosses the last line and the speed is estimated, it creates the flag to 1. And what this does is, once this flag is 1, it captures the image. And once the image is captured and saved, the flag would be 0. So the capturing image will not be called again and again when SpeedRadar is running. So in case distance is not lesser than 70, a new object would be detected and a new ID would be given to it. So this segment of code here is used for assigning a new ID to the object that's given. Finally, we have the speed function, and this function is used to find out the speed of the vehicle. It's get SP. So this number over here, I got it based on distance calculation of how much it is, and based on the frame rates. So it will depend on you if you're using a different video. But another easier way to find this is to find the correct speed of a vehicle, say like the first vehicle that's going 60, and you backtrack in trying to find the correct number. And based on that, it will relatively find the speeds of other vehicles, and you'd be able to know the speed that's going on. This one is saving vehicle data. And what this does is it basically just crops the image and it saves. So here it looks like a bit of a mess because I'm simultaneously saving the image to a file. I'm also writing into a text. So file T is basically used to write into the text file, and file over here is used to put the image into a specific file, which I shall show later. Speed limit just returns the speed limit that was mentioned earlier in SpeedRadar 2. So in this case, it's 80 kilometers per hour. And this is def end. And as the name suggests, this actually runs in the end of the program when we close everything. And it creates the summary of total vehicles and exceeded. So these variables are the ones that I've used and updated in capture. So if a vehicle crosses, count +1 is done. And if a vehicle crosses the speed limit, that's this part over here, exceeded is put 1. And it's mentioned in the file saying the speed has been exceeded. And the picture of the vehicle is stored in a separate folder called exceeded. So now I shall show the saved pictures of this. So here we have the pictures of the saved vehicle. So we have this specific ID and we have the speed also there. Also, what we have is the vehicles that cross the speed limit. And over here, you can see we have a list of vehicles that have crossed, and there's one vehicle that has crossed the speed limit. So right now there's multiple pictures, and that's because I'd executed this before and forgot to delete the pictures. So I'll just implement it one more time and I'll show you how it works. So as you can see, vehicles are crossing, and when a vehicle crosses, the image of the vehicle is saved over here. Also, this text file is also updating in the background. Also, I'll be uploading this code in the description below in GitHub. So if you guys want the code, you can go check it, and hopefully it will be useful. So that vehicle crossed the speed limit. So I guess that would be enough. Okay. So if I go here, we can see all the pictures of vehicles that were crossed, and these are cropped images of the vehicle that's there. This vehicle exceeded the speed limit, so that's there. As you can see, the number plate isn't visible, so I haven't put that there. And here we can see the number of vehicles that crossed, the 6 vehicles that's crossed, and there's one that's exceeded. Of course, the IDs might not be in the correct order, but that doesn't matter. Like that, it skipped 2 and it skipped 6, but we have a clear idea of the vehicles that passed and which vehicle exceeded the speed limit. So yeah, that will be all, and that's the complete project. Also, I'd like to thank the institution for giving me the opportunity to look further into this topic, and I'd also like to thank my image processing teacher, Swati ma'am, for guiding me throughout the project and helping us improve our concepts in image processing, both theoretically and practically as well. And that's it. I'll be putting the code in GitHub in the description below. If you guys want, you can check it out, and I really hope this helps. So thanks. Should stop the Zoom recording.